Hubert opened an account with his $1,500 tax refund that is compounded continuously. Now, see how this one says compounded continuously? So since number one is compounded continuously, I have to use the compound continuous formula. So this is A of T equals P, which is the principal, E to the RT power. I need to take the rate, which is 4.5%, and I need to put it into a decimal. There's a couple ways you can do it. You can move the decimal place 2 times, or you can take this and divide it by 100. So my principal, the starting amount is 1,500. Okay, boom. E is the inverse of natural log, so we're legit going to put the letter E and then RT. So my rate is 0.045, and then it says the find an equation to find the value of his account in T years. So I'm going to put a T to represent time. B, how much will Hubert have if he leaves the money in the account for 10 years? So my goal now is to say, okay, A of T, which is now 10, after 10 years, I'm going to input 10 in for T. Okay? Now, when we calculate this, we will get an approximate answer in dollars that is compounded continuously. We have 2,352.47. Okay? That's how long will it take him to have $3,000? Ready? So that means that my A total is 3,000, and I'm going to put 1500 E to my rate, which is 0.045, and then T. It says how long, so I'm trying to find time. Find time. I need to find the time that it takes. So my goal now is to solve this question. Okay, I'm going to go through each step in order to solve. Please take good notes on this. Ready? Here we go. The first thing I can do is take this and divide by 1,500. If I divide by 1,500, this will cancel. And what's 3,000 divided by 1,500? 2 equals E 0.045 T. Okay? This is an exponential form. My goal is to put it in log form. Okay? Exponential log form. Now, if you see an E, it's very similar to common log, where if it's a 10, you know it's common log. So if it's an E, you know it's natural log. Okay? So I can't really do like a left, right, middle thing here. So what I can do, let me do this. Instead of putting the 2 here, I'm going to put the 2 here just to show you that you actually can do left, right, middle, but that exponent has to be on the left-hand side. So if I do left, right, middle here, E turns into natural log. So I'm going to put L in. So left, right is 2, natural log of 2 equals the middle, which is 0.045. 0.045 T. So I'm going to divide 0.045 to both sides. And when I put this into my calculator, it will actually solve for the time that it takes. 15.4 what? Years. So we're using our knowledge about logs to solve this problem. So natural log of 2 over 0.045, and then you get your amount of years. Number 2, 7 fish of an endangered species were placed in a research pond. The scientist discovers that the population of fish doubles every year. So it's going to double every year, okay? Write a function to model the population of fish in the pond after 10 T years. So in the pond after T years. I'm going to put A of T. I'm always going to start with how many fish I started with. So how many fish did I start with? 7. Okay. Let me zoom in. Now, what's happening to the fish every year? What's happening to the fish every single year? 2. All right, on B, I need to find how many fish are in the pond after 6 years. So I'm going to put 6 in for T. So I'm going to have 7 times 2 to the 6th power. And then I will get a number, and that'll be the number of fish that I get. So 7 times 2 to the 6th power, you get 448 fishies. C, how many years will it take for there to be 9,000 fish in the pond? Okay, here's the first step. Let's go ahead and take our equation, and I'm going to set up the front part first. So I know I started with 7. I'm doubling. I'm raising it to the t time, and I wanted to see how long it takes to get it to how long it takes to get to 9,000. Okay. From here, the next step is to divide by 7, divide by 7. Okay. This will leave me with 2 to the t equals, and I'm going to actually keep it, 9,000 divided by 7. Okay. Now, even though this looks strange, I still now can do left, right, middle. Left, which is 2, right, which is my lovely fraction, in the middle, which is t. So if I do log base 2 of 9,000 over 7, this will equal t. 2 ways to solve this. So you can use Desmos, actually put the base 2 and this, or you still can use the change of base formula here. So what I could do is I could say common log of 9,000 divided by 7 divided by common log of 2. So approximately 10.3 years. All right, Mr. Morton bought a car that originally cost $50,000. It depreciates at a rate of 11. I'm going to take the 11 and I'm going to change it to 0.11. 0.11. Okay? Boom. Notice that this problem says depreciate. So if it is depreciating, I will not be adding, I will be subtracting. So I'm going to go and do A of t equals my principal, which is 50,000. And notice how it says it depreciates at a rate of 11% a year, which means it is annually. So I can just do 1 minus my rate, which is 0.11, and then raise it to the t power. Okay? Go ahead and type this in real quick. Go ahead and type it in real quick. Answer $12,349.52. How long will it take the car to be worth $2,000? Now, it is depreciating, so that it should eventually get to $2,000, okay? So, I'm going to take that original section, which is that 50,000. I'm going to take this, and I'm going to set it equal to 2,000, okay? If I divide 50,000, okay, I'm going to keep it just like this, just because I'm not trying to get a decimal. We're just going to keep it just like this, okay? Now this is gone, right? Now I have this 0.89 to the t power, and it equals 2,000 over 50,000. I'm going to do left, right, middle. Left, right, middle. So log base 0.89 of 2,000 over 50,000, and that will equal t. And then once I calculate this, I will get my time. Okay, so see the answer. So I got t is approximately 27.6 years.